Hello viewers, welcome to another episode. This one is going to be all about my adventures with the Quantel paintbox. Specifically, I have my Quantel Ramcorder that I used to use on my Paintbox Express here, and we're going to try and fix this issue with the corrupted video. I have looked at this before on an old video, and I kind of just abandoned trying to fix it. I didn't know really what to do to try and sort it out. So some of you might remember there was a video, I can't remember what it was now, probably last year sometime, when I looked at this, trying to fix it, and didn't really get anywhere. I think I basically came to the conclusion that it was a problem with the video serializers, which output SDI video to the paintbox, and I think I put that down to these chips here, which are STV1601s. These ICs were actually made by Sony originally, back in the day, called the SPX 1601. I think Sony sold the design to ST Micro, and they started making them under the different model number, STV 1601. Now these chips were notorious at the time for going bad, and I think that's basically what's happened. Ramcorder. So with the help of a couple of good friends, I'm going to be looking at replacing this IC with a, I'll say a modern replacement. It's not really a modern replacement because it's out of production as well. But it is a lot more modern than this, and it should be completely reliable. So let me turn all this stuff off so it's a bit quieter, and then I'll show you what I've been working on. So what I want to actually do is replace these ST Micro STV1601 SDI serializers with something that actually works. Now, thanks to a couple of other people who are Electron Ash and Mike, thanks to you both for all your help. What we've actually been working on is a small board that can plug in place of the 1601 and replace it with a more modern alternative, because thankfully the data streams that these take in are completely standard, and what Quantel have done is they've used some CPLDs and FPGAs to convert their internal video into a completely standard Rec 601 stream, which can go straight into the serializer and then go straight out to the outputs. So this does mean that there are lots of modern alternatives out there. SDI is very, very common. Now we had a look around at several different chips. Not all of them were ideal. The most modern ones, which would have worked, they tended to not to be 5 volt compliant or tolerant. This is all based on old stuff, so it's all 5 volt. So we needed something that was 5 volt tolerant. We needed something that was small enough, that was cheap enough, that was available, and we basically came down to this particular chip. It's from Texas Instruments. It's the CLC020. Now this isn't actually a current product, it's actually discontinued now, unfortunately. It was an expensive device at the time. I think they were about £20 each, which is a huge amount of money. But I did a bit of looking around and actually found a Chinese seller selling new old stock of these for £5 each. Now, given I'm not going to need a lot of these, and the seller has plenty available, I thought this was probably a good solution. So I bought 2 of them, and we've also designed this PCB, which is going to sit in place of the 1601 and do the SDI conversion. So there's not really much else needed on here apart from a few passives. So, as you know, I have a channel sponsor, that is PCBWay. They provide a quick turnaround PCB prototyping service. They can make pretty much anything you could possibly want as a PCB. So they've sent me some samples here. These look really, really good. Yeah, totally happy with all the samples that they've sent. They look absolutely fine to me, and they have also manufactured the circuit board that I designed to hopefully fix this 1601 SDI serializer issue. We're going to look at this in a little bit more detail in a moment. So I'd just like to thank PCBWay for manufacturing this for me for nothing. And it only took, I think it was 2 days to actually manufacture and then a couple of days to get here. So really, really quick turnaround. So if any of you out there have any PCB prototyping needs, then go check out their website at PCBWay.com. And links will be also down in the description. Right, so let's have a little bit of a closer look at this board that I've designed. So what we have here, this is the video input-output board from the Ramcorder. On that there is two modules. We've got this one here and this one here. One receives SDI and one transmits. So this provides the mechanism to transfer the video between to and from the Ramcorder and the paint box. So this particular one here is the SDI receiver that takes SDI input, deserializes it and then converts it into the internal video format that's used in the Ramcorder. And this one is the opposite of that. It takes the video, converts it into Rec 601 or BT 601 format video, and then sends it to the serializer to actually go out as serial digital video. You might notice I've actually got a couple of heat sinks on these. This was my vain attempt to keep these STV 1601s, that's the 1602, working. Obviously it didn't work for this one. I think for some reason the receiver seems to be more reliable in the long term than the transmitter. So if I just remove the 1601 that I've actually put in a socket previously, you can see there the pin grid array, if it focuses, with the heatsink that I put on it. So what's going to happen is I'll be mounting the CLC 020 on the back side of this and with a few passives, and then that will sit on there. The reason why I ended up using a 2-pin header to transmit the SDI is because that's what Quantel used on this originally. There is a really, really bizarre 2-pin coaxial socket which actually plugs onto these pins here, which is really, really bizarre. I didn't really want to start messing around creating new cables and stuff, so I thought, well, I will just add some pin headers onto this board here. Now you might ask, why don't I just transmit the SDI down through whatever pin it would have been on the 1601, and I wouldn't have had to add these onto here. Now the difference between the 1601, this device, is it doesn't actually provide the line driver for the SDI cabling. That is done by a separate chip, and that's this one here. So this doesn't really provide enough grunt to be able to drive an actual cable. So what they've done, it drops down through a small little circuit of all these passives here into this IC, which provides the actual line driver output, which is then sent to these pin headers. Now the CLC 020 has a built-in line driver, so I don't need any of this. I can literally just bypass it, and that's basically what I've done. So instead of sending the SDI down through the existing connections to the line driver, I don't need to do that. So I can just add 2 pin headers on here, and the cable that plugged on there will just plug on here instead. Now you can probably also see a couple of other pads that I've got on here, these ones just down here. This is for a built-in test feature of the CLC 020. You can enable a test mode and it outputs test patterns according to various settings on these 4 data lines here. Now what I'd planned to do originally was actually build this up and then supply it with power separately, supply it with a clock, and then literally the board on its own would have provided SDI test patterns with nothing else. But as it turned out, I forgot that my function generator only goes up to 20 megahertz, and it needs 27, so I'm not going to be able to use that feature. So the test pattern generator probably isn't really going to be much use. It'll literally be a case of plug it in and see what happens. because once it's plugged into this board, I won't then be able to use these data lines here for the test pattern settings, because it will be connected through down to the rest of this board. So obviously we're just matching up all the connections that would have been on the 1601 to the CLC 020. We've got power coming in, we've got some decoupling capacitors, we have an LED for signal lock, that's just here. I don't actually have an LED of that size at the moment, so I probably won't add that in for the time being. We've got a test pattern pad to enable the test pattern generator. These four are the pads that define what the test pattern will be. We have two SDI outputs. There's two capacitors here used for decoupling on the actual SDI outputs. If I just flip this over, we have the actual footprint of the CLC 020, a couple of resistors here providing termination for the SDI outputs, and there is one resistor just here that sets the SDI output level. So in terms of actually plugging this PCB into the turn pin sockets that I've already installed on here, I'm actually just going to be using these little pins that I've salvaged out of other bits of Quantel stuff. It's got a nice little pin which can just plug straight into those sockets. So that'll be that. So what I'm going to do is go away and solder everything up. I'm going to do it off camera because I've not soldered anything this small, and I don't really want a camera sat in front of me while I'm doing it. Okay, I've got that all soldered up now. Bit of a challenge doing the 0604s. I think I will go up to the next size up next time. It was a little bit of a challenge, but I've got there in the end. I found a few mistakes. The right angled pin header, I didn't account for mine being in that arrangement. I probably should have checked. I thought it was like these ones here. You can see there the plastic sits over the actual through hole, but on the ones I've got, they don't, which means it kind of gets in the way of the capacitors which are underneath. Simple mistake. I robbed a tantalum cap off one of the older Quantel boards. Hopefully that won't explode. And I also spotted some electrical issues. Just some simple pin mix-ups, and there was a couple of pins that had been tied to ground which were shorting out the -5 volt power supply in the Quantel side. So all I've done, I've just removed those two pins that were causing that. There was another pin which was the power supply rail that was mixed up with a pin next to it, so that one is easy fixed as well. So just remove the pin and then just put a little jumper across. So everything checks out. There's no shorts or anything now, so I'm going to plug this in and we'll cross our fingers. Right, so as you can see, we have video. Now it's not been quite as simple as that. When I first plugged this in, nothing happened, didn't get any video, so I did a bit of tracing around and actually found another little error on the schematic, and it meant the picture clock wasn't getting clocked into the CLC 020, so that's why that wasn't working. So quick correction, quick jumper, and that sorted that one out, and we have a picture. Now the interesting thing is this works really well like this, but if I close the case up, I start to get corrupted video again. So I think what might actually be going on here is there's kind of been two faults. Possibly that 1601 serializer chip has started to go a bit iffy, and I think there is a dodgy connection somewhere on this system, because if I close this up, I'll show you it in a moment, but if I close the case up, I start to get corrupted video again. So there's definitely more needs to be done with this. Right, so I hope you don't mind me going handheld. It's just a bit awkward to get everything in. So you can see the Ramcorder there, it's open at the moment. So if we look around here, you can see the little board, and you might also see a bit of purple kynar on there to correct the picture clock. signal which wasn't connected, but that is actually now working. Now if I, as I said, if I actually close this case up, I start getting corrupted video again. So I think what I'm going to have to do is start having a bit of a play around, poking things quite literally, and see if I can start to get it to corrupt the video again, so I can potentially track down this other issue. Of course, the good news is these chips do work as a good replacement for those STV1601s, so that's really, really great news. Right, what I've been doing is just going over this, trying to find anything that might cause this secondary sort of glitch issue that I've noticed. I've tried everything, prodding, poking, jiggling, wiggling. I've turned it on its end, upside down, had it open, closed. Yeah, I've tried everything, basically. Now, the only thing that actually made a difference, as I started to notice when I was sat here just like pondering, looking at it, I'd closed the case up. It had been working. I closed the case up and I noticed that it, once the case had been closed, it worked, and then it just slowly got worse. And I started to think, I wonder whether this might be some kind of thermal thing. So I did some experiments. I closed it up, turned it on, left it for a bit, and it indeed was, the video output was glitchy all over the place. And what I did was I blocked the fans up to let it warm up, and the glitching stopped. So I was like, right. So I've just had it open. I've been all over this with my freezer spray. Well, it's an air duster anyway. So I've been over a lot of the stuff with a freezer spray, and I think I've tracked it down to, it's either the 1602, which is the SDI receiver. Now, one of the reasons why that could cause an issue is the output video is synced to the input video. So if there's an issue on the SDI receiver, which takes the video from the paint box, then there could potentially be some kind of synchronization issue. It's not passing through the clock and all that sort of stuff to the outputs. That's a possibility. But I actually noticed that the capacitors on this board are really sensitive. So I'm going to suspect that these caps are probably bad. You know, they're 25 years old, little surface mount ones, so I think there's quite a possibility that they're going to need changing. It's a bit surprising I didn't think about them before, but when I think about it now, Quantel stuff very, very rarely uses electrolytic caps. They just use tantalum or ceramic, so I've never really had to change any on any Quantel stuff. So yeah, it just didn't cross my mind. So what I'm going to do, I'm going to unplug this SDI receiver board. I'm going to pop off these three electrolytics. They're just, you know, completely standard 100 microfarad 6 volt, I think. There's two on this board as well. I'll probably try and change these at the same time, and we'll see if that makes any difference. Right, so I've just been through and replaced the 1, 2, 3, 4, 5 caps on these two SDI modules. Yeah, you'll notice there's a through-hole component there. Unfortunately, I lifted a pad on when I was removing the cap on this one. So what I've had to do is just tack on to a via that was still there. So I just had to use a through-hole part there. A bit of a disaster, really, but these things do happen, especially when you're working on old stuff like this. But thankfully the ones came off okay. They've all now been replaced. These were all bad, apart from one. The worst one, I think, was coming out at about 45 microfarad and an ESR of about 40. So yeah, there was definitely a couple of those which were way past their sell-by date. So I'm going to plug this back in and power it on, and we'll see what happens. Right, I've got everything kind of connected back up. I've got my paint box running into my Ramcorder, but the output is actually coming out and going through one of my video scalers. It's not going through the paint box. So the output of the Ramcorder is going straight into the video scaler and then onto this monitor. The scalers that I have seem to be quite sensitive to bad SDI, so it might actually be a bit of a better test than plugging it into my paint box. So at the moment it's showing a blue screen because there's no signal. I'm just going to turn this on and we should get a page of a screen of random noise, but it shouldn't flicker or do anything bad. So and that is kind of what I expected to see. Excellent. Yep, I'm just pressing the reset button there, so that's what's changing the picture there. Ooh, right, okay. I need to rearrange all this, plug it into the paint box, and we'll see whether we can actually get some uncorrupted animation out of it. Right, so paint box is on, Ramcorder is off, it's connected up, so let's just turn that on. It's all closed up, so hopefully I can just leave this as a bit of a soak test, make sure it doesn't do anything funny. So if I go to animation Ramcorder, I should be able to scroll through here. It should be a nice stable picture, which it does seem to be. Alright, now if we go to animation, oh, it looks pretty good. Can't see any corruption. Box is all closed up. I think what I'm going to do is leave this playing back for a few minutes. So yes, this looks like a fix at last. Oh, I've been missing this machine. So yes, excellent. So this basically means that I now have a Quantel Harriet Express, even though I don't think that model actually really existed. But yeah, we have what looks like success. We've got a nice Paintbox Express with a Ramcorder. Fingers crossed this is going to stay like this. It's not going to go funny on me in the next couple of days. Managed to get a replacement for the STV1601 SDI serializers. That's great news because I know of another Ramcorder and a Paintbox that potentially have bad ones. So there's definitely scope for replacing those with those CLC 020s. And yeah, I've got my Ramcorder working again, which is great news. So thanks for watching, everybody. Thanks to all my patrons. Thanks to PCBWay for sponsoring the channel. Awesome work by everybody. Thank you very much, and I'll see you on the next video. Bye for now.